So we're looking at this, and it says for which, number 18 says for which value of x is the quadrilateral a parallelogram. That means you have to on purpose make it a parallelogram. Okay, that means that you're going to be saying, oh, these have to be bisected. So 2x plus 4 has to equal x plus 9. Moving our x over, we get x equals 5. By the way, we're on page 562 if you haven't kept up with where we are. Okay, on the next one, the same thing is true. You need to recognize that for it to be a parallelogram, it has to have bisected diagonals. They're driving that point home. Okay, so 3x plus 2 has got to equal 5x minus 4. Moving your 3 over, you get 2x. Moving your 4 over, you get 6. Divide by 2, and you get x is equal to 3. All right, classify the special quadrilateral. Now you're looking at your theorem list because you have all the characteristics of quadrilaterals. Then find the values of x and y. Okay, this is a parallelogram. Oh, it's got this right angle. The diagonals cross at a right angle. That makes it a rhombus. And we know several things about rhombi. We know that it's a rhombus if the diagonals are perpendicular. We also know if its angles are bisected. So that means y is 21 degrees. Now, since this is a right angle, we can find this angle here by saying, okay, here's a triangle. I want to make sure you can see the triangle. Whoops, come back here. Okay, here's the triangle we're looking at. And that's 180 degrees. So together, these have to equal 180 degrees. So 90 plus 21 is 111, and subtract from 180, and you get that this angle is 69. Well, remember that in a rhombus, the angles are bisected by the diagonals. So you know that this is also congruent. That makes x 69. And it is a rhombus. Remember, we knew it was a rhombus from just looking at it because it had perpendicular diagonals. Okay, I'm going to declutter. All right. And we look at this one and we see that it has 4 right angles, so we know it's a rectangle. And then we're going to apply what we've known about rectangles since elementary school, that the sides are congruent. Then we're going to combine that with a little bit of algebra that you've already learned. And we're going to say 4y has to equal 6y minus 10. So you're going to move your 4y over, you're going to get 2x equals, moving your 10 over, positive 10, so x is 5. And then 4y, all right, 4y equals 6x. Good grief. Those are all supposed to be y's. I can fix it. Equals 6y. And you were at home laughing because you said, she's going to fix that in a second. All right, and then looking at the other two sides, we have 3x plus 4 has to equal 4x minus 5. 3x plus 4 equals 4x minus 5. Moving our 3x, we get x equals 9. And y, we said, was 5. Okay, then it says, the diagonals of a rhombus are 10 centimeters and 24 centimeters. Find the length of a side. Explain. Well, it might be helpful to draw a picture. I guess you don't have to draw a picture. But if you get it wrong and you didn't draw a picture, I'll be saying, why didn't you draw a picture? Okay, remember that that's going to give you a right angle there. says the diagonals are 10 and 24 centimeters. We can see that this is the short way, and it's 10 centimeters. Let me use a different color so it's easier to see. Okay, we know that this is 10 and going across here, and we know that the other way is 24. And we're looking for the length of a side, and since all the sides are congruent, it'll be the same. Okay, so you realize this is a right triangle, and we've got a 5 here because that's half of 10. These are bisected. We know that because it's a parallelogram as well. And then going this way, we have 12. So I think this is probably a Pythagorean triple. Let's find out. Okay, so using the Pythagorean theorem, x squared would be 5 squared plus 12 squared equals c squared. Okay, this is our hypotenuse. It's across from the right angle. 25 plus 144 is 169, which indeed is a Pythagorean triple. That makes this side 13. 5, 12, 13. Okay, and the way that you would explain that is you would say the diagonals bisect each other, and half of each diagonal makes the legs of a right triangle. Pythagorean theorem. Use it. Okay, decluttering and moving along. Okay, this one says, in exercises 23 and 24, use the diagram of the recycling bin. Thank goodness we don't still use recycling bins that look like that. Sorry. One end of the container is an isosceles trapezoid with FG parallel to JH, and the measure of angle F is 79. So we're going to just mark our figure. Always mark your figures, at least if you're doing that. That's good. 79 degrees. Okay, and it says, find the measure of angle G and H and J. It's an isosceles trapezoid. Looking at your theorem list, you see that the base angles have to be congruent. So we have, these are base angles. Even though it's not sitting on that, they're base angles because they're part of the parallel line. So this is 79 degrees as well. And that means that because these are parallel lines, these are consecutive interiors. So they have to be supplementary. So 180 minus 79 equals 101. So each of these has to be 101 degrees. Now it says copy FG, HJ, and sketch its mid-segment. Okay? FG, HJ. FG, HJ looks kind of like this. G, H, J. Now we're going to find its mid-segment, this nice isosceles one. Okay, the mid-segment is 16.5 inches long, and FG is 19 inches long. Find JH. Okay, using our Laney, remember Laney told us that, well, Laney told me last year, that the easy way to do this is to say, oh, it has to be right in the middle of those two numbers. So if you subtract 19 minus 16.5, you see that it's this distance between those two is 2.5, so it has to be 2.5 this way as well. So 16.5 plus 2.5 is 19. Now I know there'll be those of you who want to know how to do this algebraically. using our Laney. Okay, so to do that, what you're going to do is say FG plus JH divided by 2 is 16.5. So we know FG, that's 19, plus JH divided by 2. Now we know this because we have a theorem written on the theorem list that says that the mid-segment is the average of the two bases. When we average those two bases, we get 16.5. To get rid of the 2, we're going to multiply both sides by 2, causing this 2 to cancel. So we get 19 plus JH equals 16.5 times 2. And that's going to give us 33. And then subtracting 19 from each side, we find that JH is indeed, got 19. Whoops. I needed to subtract 2.5 from here. See, that's one good reason why you should do it both ways. 16.5 minus 2.5. I'm not starting this video over. 14. I figure at least we can have some fun. If we got to do this together, I don't actually mind doing this. It's kind of fun to be with you guys, even when I'm at home. Okay, so when you subtract 19 from each side, you get 14. So JH is 14. That's a good reason to write all your stuff in, because you can make errors like that too. Hey, you're learning from the best. All right, give the most specific name for this quadrilateral. All right, now be careful, because you can't say what it looks like. You have to say what you know. We know we have a quadrilateral with 4 equal sides. We can only say that's a rhombus. It looks like a square, but we can't say it's a square. It does not have right angles. All right. Let's see, 148 degrees and 132 degrees. Let's see. We need to find out if these are parallel. Okay, so we're going to add 32 plus 148, and we're going to see if it equals 180. It does. And so we can say that we know this is a parallelogram. Can we tell that? We cannot tell that, because, one of the things you can do to help you figure out stuff like this is ask yourself, just because these are these angles, does this one have to be 32? Could it be like this? Is there anything to prevent that from being bigger? No, there isn't. So all we can say about number 26 is that it's a trapezoid, because it has at least one set of parallel lines and the other set is not marked. So we don't know. That's the most specific we can get. Trapezoid. Okay. I noticed that if you were with me the other day, there is no saxophone in the background. Just saying. All right, we know that 7 is congruent to 7. So we have opposite sides being congruent. We have nothing about right angles. So this is a parallelogram, since all we know is that opposite sides are congruent. Okay. In quadrilateral RSTU, RT and U are right angles, and RS is congruent to ST. What is the most specific name? Okay. RSTU are right angles. RT and U, sorry. RSTU, and we know RT and U are right angles. Well, S has to be a right angle, because that's all that's left. So we know it's a right angle. We mark that because it wasn't given. And then it says RS is equal to ST. RS is equal to ST. Okay, well, if those two are congruent, then all 4 of them have to be congruent, and this has got to be a square. Okay, if any of these were longer, that would make those not right angles. So that's why it has to be a square. Alright, that finishes up the review. There are some more practice problems that you can do to prepare for the challenge test or for any of the other tests, so take a look for the other videos.